Welcome to episode 3 of the Obscast. I'm Joe Gathercole, and today I'm your co-host because co-hosting alongside me is Rob Dawes, the chairman of MSAS. Rob is here with me tonight for a very special episode of the Obscast. So hello to you, Rob, and a big hello to our 3 guests. They are all founding members, and without them we wouldn't have a society to talk about today. We have David Collins, Gordon Jones and Graham Shepherd, so thank you all very much for being here and making the time for us tonight. We are here tonight to discuss the history of MSAS, so I'd like to ask a question right at the beginning, if that's okay, and ask what was the spark or the driving force that led to the creation of MSAS and the building of an observatory?
It all really started with a night class, believe it or not, on astronomy, held at the art college on Westgate at Mansfield, and the course was run by a fellow by the name of Horace Barnett. Now, he was the creator of Newbold Observatory, which was the home of Chesterfield Astronomical Society. And one evening, whilst having coffee, Horace and I were chatting, and he asked me if there was an astronomical society in this area, and I said none that I knew of. In fact, I didn't know anyone interested in it. Oh, that's not quite true. I did know Bill Henshaw at the time because he worked for my dad at Pleasdick Colliery. But anyhow, Horace Barnett said, have you thought of starting a society? He said he seemed to be very interested in the subject, so I said no. He says, well, why don't you put an advert in the local paper and take it from there, which is what I did. And then shortly after that, one evening there was a knock at the front door. Went to the front door, opened the front door. There was Gordon Jones, Bill Henshaw, and one or two other people as well.
Can't remember, Dave.
You know, it went from there. Then the company I worked for, an engineering company, made industrial knitting machines down on Unwin Road in Sutton, and I had a chat with them, and they allowed us to use their apprentice training department for the inaugural meeting. And in fact, beyond that, they allowed us to use it for the society committee meetings. And that's really how it all came to fruition. And I'd got a book at the time, which was called Handbook for Telescope Making. But it was an American publication by a chap called N.E. Howard. It was 320 pages thick, and it told you just about everything you wanted to know about building a telescope. Started at the beginning, considering what size telescope you wanted to make, how you were going to tackle the problem, and so on and so on. Went right through making the mirror, making the telescope, making the mount, making a run-off observatory. And I thought, well, this looks like having to be the Bible. But Gordon came along, and he'd already built his own telescope and his own observatory, and you helped with Bill Henshaw as well, didn't you?
I helped with Bill as well, yeah.
So, straight away, somebody with bags of experience, throw the book away. And that's how it all came to fruition.
So it sounds like it all came together very quickly. Can I ask, what was the spark for each of you to get into astronomy? What was it what piqued your interest so much to really grasp astronomy? It's been a lifelong friend to you from all accounts.
I first got interested in astronomy, I think, in about 1953. There's a programme, a series on the radio one night a week. I think it was on for about half an hour. It's called Journey into Space, and it was serialised. It ran for 5 years actually, and it was quite interesting. You know, I quite enjoyed it. And then in '57, we had quite a spectacular comet at the time called Aaron Rowland. Now this was a comet with the anti-tail sticking out at the front of it, which we now know it was just more or less an optical illusion. But it was quite a prominent object, and that's when Sky at Night started on television. The first programme was about this comet, and from that moment on I was totally hooked on the subject.
It sounds like Journey into Space with a forerunner or the blueprint for the Sky at Night. What about you, Graham? What kick-started you on?
How did I get into it? Well, probably as David's already mentioned, Sky at Night lit the fuse paper. I then looked around for somewhere where I could get a few questions at it, and I wrote to the then secretary of the Nottingham Astronomical Society, Miss Mott, back in 1961, and subsequently I joined up. And then they had their 8.5-inch telescope that was being looked after by Mr. Lane Hall, who lived out at Keyworth. Nice dark sky location. Mr. Lane Hall, he worked in the architects department of the local council. The years rolled by, and yes, that telescope was nice. Well, a good idea to probably try and build an observatory. Didn't realise what would be needed, but the years ticked by, and we had an outing to Chesterfield Astronomical Society, their observatory. I thought, yeah. So subsequently I digressed and I joined Chesterfield. And during the time there, of course, I met up with David and Gordon, and David's already described how MSAS kicked off. Yeah, it's been a fascinating journey, but of course you always have to recognise just how things have evolved then. Yeah, if you wanted to, I think initial captivating thing for most folks is when they see through a telescope. Okay, yeah, back in those days, the 60s, 70s, if you wanted to do astronomy and you wanted to see stuff out there, that's all you could use. But was it early 1970s, was it Mariner went out to Jupiter, Mars? Anyway, the space probes started to go out to these places, and of course we know how the subjects transformed subsequently. So now virtually, you can virtually type any object into your computer and you got all the information there, as far as we can deduce. Yeah, the questions, okay then, is there life elsewhere? Yeah, we believe, okay, did the universe start off Big Bang steady state? How about multiverses? Well, my idea, nature never does things once, it tends to repeat things, so more than likely it will be quite a complex structure out there, and again, it depends just which order of scale you consider. Yeah, you go down to the atomic level, things are very small, come up to where we're sat around the tables here, out in space that's really big, and Lord knows how far do you keep going, which you simply don't know. Okay, the James Webb has made some progress very rapidly, quite recently, looking farther out, but we will learn more, but I don't think we'll ever learn everything. Yeah, the problem, even just making it to Mars. Okay, we struggled a bit with the moon. We just about managed the moon, but somebody said, as I read, okay, we have, David's been to Antarctica. We've been there. Humans have visited there, but there aren't many urban councils there. We can visit there, but it's not very habitable. It's fairly hostile. Same sort of thing with Mars. Okay, it's there. We may manage to send humans there, but I think for full-scale inhabitants, it's probably not practicable. okay, our sun will expand and burn Earth up and I suppose possibly fringe Mars, in which case we might go and live on Europa or was it Enceladus? But yeah, these things are in the future. But make no mistake, okay, we can easily look at things on the internet, photographs of objects, but the difficulty getting out there to touch these places, few as we can access, well, that is frightfully difficult. And of course, the one thing which continually happens, the clock never ceases ticking. Yeah, we're mortal and, well, I won't go into that anyway, but we know.
So before MSAS, you had a history of being in astronomical societies.
Yes, I did MSAS, did Nottingham and Chesterfield. Oh, we used to travel. I used to travel all over the place. They had the British Astronomical Society. They had meet down in Burlington House in London. And they had provincial meetings and had annual ones down at Winchester. And so you probably see Paul Bell listed on the list of members. In actual fact, he's on one of those early photographs when we were digging the foundations out for this. But Paul and I annually used to go down to these BAA meetings at Winchester. And roughly about 1971, one of the lecturers started talking about solar eclipses. And he says, well, in 1973, there's going to be an eclipse, and it's going to be distinguished by having the longest theoretical period of totality, 7 minutes. They're a travel company. They organised a cruise, the Track of Totality, that ran over the Atlantic Ocean, over the west coast of Africa, continuing along over the Sahara Desert and over the east side of Africa. Well, I found a company that was going, they did safaris from Mombasa up to, what's that place? Algeria. And they had a spur for the folks who wanted to go and watch this eclipse. And there were 6 of us. So I joined this and we ended up at a place just north of Agadez in Niger, in the middle of the Sahara. I was working with Boots. They lent me a telescope, they lent me a camera, so I went over there with 2 telescopes, 2 cameras, took lots of 35mm slides. And I suppose so far as travelling around the planet, that was a fair old highlight for myself.
Absolutely, what a fantastic journey on your astro travels just in that section. Gordon, what kick-started your interest in astronomy?
15-year-old, obsessed with the moon. And of course, I borrowed one of my uncle's binoculars, and I used to sit looking at them hours and hours. Could do nothing about it, as a kid anyway. But eventually I got married, and then I got my own property, and I'm into engineering, so I thought this is a golden opportunity. So I ground and polished a 9-inch mirror, built a telescope, built an observatory, and I could start looking round. That thrilled me no end. And then when I saw David's advert in the paper, because me and Bill Henshaw were going to Chesterfield at the time, saw David's advert, so we went and seen him. And we all got together and we started Mansfield Astronomical Society. All right, it was humble beginnings. We didn't have anything. But of course, we kept going to Chesterfield as well. While I'm at Chesterfield, one night, one of the people who actually came to our first
inaugural meeting.
meeting we had at Monks's was Horace Barnett and another fella,
Ian Islop.
was Ian Islop. And of course I'm saying to Ian Islop of what I think we can do as an astronomical society. And Ian says, you do realise you'll always be playing second fiddle to Chesterfield because we have an observatory,
Big
we have
mistake.
a telescope.
Big mistake. You don't challenge Gordon Jones.
So I thought, oh right, so yes, so anyway I thought, and when I was saying to David, I'm going to build a telescope. Sorry about that. Build a telescope and we'll build an observatory.
Is that where it came from then? To the driving spark to build MSAS from that comment?
Yeah,
Competition.
Well, in a way, yes, but like I've just said, you don't throw challenges down to Gordon. I mean, Gordon was is already explained. Gordon was an engineer. Now, what Gordon could do you recall a few years ago on television, there used to be a program called Scrapyard Challenge. Gordon was like, you could give him a bucket of bits and pieces and come back in an hour and he'd make something useful out of it. And of course, once they threw down the challenge, whoa, you won't do it. So Gordon came back, reported to us and says, right, okay, we'll do what we can do. So we got our heads together, we formulated some plans and one thing and another. We had a trip over to Lincoln. They'd just completed their lecture room. So quite a nice structure, probably about the same size as this building, kitchen, blah de blah de blah. And outside, on the opposite side in the car park, was a circular structure about 2 foot off the floor, which was the commencement of building the observatory. And we asked the question, right, what's happening with that? The members have lost interest, they've had enough of brickwork and that, they lost interest. So straight away, Gordon latched onto this and said, right, if we build a combined unit, observatory, lecture room, you start one, the other gets finished. So on that basis, we had another trip out to Stoke-on-Trent. Remember the Pace brothers?
I do, yes.
Now they had an upstairs type observatory like we've got. Of course, the other thing is doing what we've constructing the way we did construct it give us more room for parking. Plus, it lifted the telescope up, over the mound of the reservoir there. Another thing as well, that Gordon had mentioned about Chesterfield Observatory. Their dome was manual. You had to push the dome round, and the aperture was done by ropes, which were dangling down over the telescope. Gordon says, I don't like that idea. So I said, well, we'll motorise it. Gordon says, I'll leave that one with you. Because that was what I was doing down at Monk's. I was electrical engineer. So, 3-phase motoring and all this control gear and one thing and another was everyday thing to me. But it was challenges and things like that on the way. Right. I mean, we went up to Grub Parton. That's where we first met Dave Sinden. Now, Dave Sinden and his colleague Dave Brown, they were considered the world's best optical engineers at the time. When we got there, we walked into their big structure, and the first thing we bumped into was a 98-inch Isaac Newton telescope.
It was, yeah.
Ready for departure. Anyway, we chatted to Dave, and he gave us a lot of ideas and one thing or another. And he told Gordon straight there, he says, right, I'm behind you all the way on your project. He says, any problems, pick the phone up and ring me. I'll never forget Dave Sinden saying that. Pick the phone up and ring me. And it was then when if I remember rightly, if I've got this right, it was then when Dave Sinden suggested using plate glass to make the mirror, because obviously. I mean, we started with nothing, and we've got most of that nothing we've still got. You know what I mean?
Biggest problem we had, when you make a telescope, you use Pyrex, low expansion glass. I, in my infinite wisdom, because Chesterfield had got an 18-inch, and Lincoln were on about building an 18-inch, after my little run-in with Bob, I thought, I'll make it 20-inch, I'll be bigger than your bugger. And then I thought, no, I'll make it 24, 6 inches bigger. But of course, did present a problem getting Pyrex glass at that diameter. That's when we were talking to David Sinden, make it out of plate glass.
So you pointed out that there were professional telescopes being used with plate glass mirrors, i.e. the 16-inch at Mount Wilson and the 100-inch hooker that Hubble had used for his classification of galaxies. Now, there was a bone of contention there with that, with Edwin Hubble and the 100-inch hooker, which has been my bone of contention with the 24-inch here, because it's plate glass. And he was well aware of the vagaries of plate glass in varying temperatures. So when he found out that Ellery Hale was planning on building a 200-inch Palomar telescope, Hubble descended on him and he says, whatever you do, do not have it made out of plate glass. The suggestion at the time was to use quartz. So they approached Corning in New York and just casually in conversation, Corning suggested that he says, why don't you try this other material we've got, which nobody had heard about, Pyrex. Now they'd started making Pyrex round about the turn of the century, 1900, mainly for laboratory equipment. But the story goes that one of the team, he took a piece of this Pyrex glass over and he asked his wife to make a pie in it and stick it in the oven. And when it was cooked, he took it out and the glass was still perfectly intact. So that was the kick-off of Pyrex low expansion glass. And
so all these chance encounters ultimately started leading one direction.
That's right.
For MSAS.
Absolutely.
All these connections were building
we
up.
took an awful lot of information and advice on board, and we kept it prominent in all the aspects. I mean, we treated the whole building as a stage of projects.
So when initially you guys got together and you started thinking about going up to Grub Parsons, how many members did you have signed up
At the
to
time,
be involved?
about 10 or a dozen.
10?
Something like that. There weren't that many, were they?
Right in the very early days when we came up here, you know, when we started work, the first thing we did was get up here on Sunday morning, and then we all got together, put our hands in our pockets, so one of us could nip down to Wicks and get 3 or 4 bags of cement. Yeah. That's how it went.
I was going to ask about the first step of creating a physical presence for MSAS is acquiring land and a site to build on. And how was the current site secured, and what were your requirements while looking for somewhere to be?
Our first approach, we went to Mansfield District Council. They offered us a piece of land right at the top of Brickhill Lane, which was facing directly west. It wasn't a bad site actually, but whilst we were in their office, he went to his drawer and pulled out this huge roll of paper and rolled it out, a massive big plan, and it shown the plans for this, what they call the Mar Road. This is this road that runs down here past Amazon, which runs from the top of Plesley Hill across, up by the Fox and Crown, down past the hospital and then up here. And he said that that plan was in the parkline. He says, and the street lights might be a bit offensive to you, so we scuppered that programme. We turned to
We did.
Sutton Council,
Mal-
and
Malt Roebuck, he joined us then.
yeah,
And Malt worked with a man named
Ted Redford.
Ted Redfern. And Ted Redfern was on the council, Sutton Council. He were also on the board of the Central Notts Water Board. And he was, when Malcolm were talking to Ted Redfern, he said, "Oh, Mansfield, they all dead up to the neck down there. We want it in Sutton." And of course, they got to Mr. Lear, who was, his name Lear, at Central Notts Water Board. He was Clerk Treasurer. Yeah. And he says, "Well, we've got a bit of land up at Coxmoor, side of the reservoir. Would that be suitable?" It's highest spot in, well, second highest spot in Nottinghamshire, so it were a good, so we came up, didn't we? Walked round the reservoir, I had a look, I thought, yeah, it'll fit in here nicely. The bank was a bit close. They want as much room as there is here. So as we started digging, when we bought the land eventually, again, I think that was through David, because we decided to have a sponsored walk to raise the cash to buy the land.
Can you remember how much it was?
50 quid.
£50.
We put a bid in for 50 quid, and they were only our bid, so we got it.
One of the sponsors, Terry Paling, insurance broker, he did the insurance for the equipment down at work at Monks. And Arthur Clayton, who was my departmental manager, was also a founder member. He was a good friend of Terry Palin. So Arthur said to him, he says, "We're doing this sponsored walk for this project. Would you sponsor me?" Terry Palin sponsored Arthur Clayton to the tune of 50 quid.
Which were convenient.
Job done then, yeah.
So when we would acquire this land, because when the society was first formulated, we called ourselves Mansfield and District Astronomical Society. But when we acquired this land, Malcolm Roebuck suggested, "Well, now we're here, why don't we change the name to what it is today, Mansfield and Sutton Astronomical Society?" Yeah, good idea, we'll do that. And so that's how we have the MSAS is 50-year-old, whereas the society in itself is
The thing is,
52-year-old.
we got the land, we didn't have to do anything, only do a sponsored walk. So we got the cash to build it. Malcolm Roebuck's, one of his nieces, or one of his relatives, worked for a solicitor, and they conveyed the land free. And we've not got no record of them anyway, because I've searched high and low for it. No record of that. I've got to have a word with Malt to find out who it was. So we got the land conveyed for nothing. And then, of course, I was at Plesley Colliery at the time, and they decided to knock the canteen down. So we all went over to Plesley Canteen, and we gave them hand. And all the roof concrete, sections for the roof now are over at Cesspit, which is where your telescope
I was going
is.
to ask where all the materials came from.
Yeah, and all the brickwork and all the things, bricks for the cesspit and for the building, all Plesley Canteen. And we had that transported by
Tony Enwood.
Tony Enwood, and he transported it in his lorry up here for nothing. We got everything going for us. We couldn't have wished for anything nicer.
Then this was at the time when they were knocking Middle of Mansfield apart to build the Four Seasons shopping centre. So one of our colleagues went down, sought out who was in charge of that, and says, "What do you do with all the brickwork and that? You're knocking all these buildings." "Oh, we're going to tip it up." "Can you tip it up here?" "Yeah, just drop the driver a quid." A quid.
Yeah.
So when we started building, I mean, the thing was then, some of those properties were 200-year-old, and there was no bricks were all different sizes. Because when we started building it, it looked an arsehole. And Gordon came up with a saying that took us all the way through. It'll come right on the last score. It'll come right on the last score. And it did. And Ted Redford says, don't worry about it. He says, when you've done it, he says, slap some rendering on it. He says, and
That's right, yeah, we did, yeah, true, yeah.
Yeah, so this is how we went. It was, looking back on it, it was unbelievably helpful.
It was, yeah.
Unbelievable. Ted Redfern says, look, I'm the building inspector. He says, I'll keep popping up and having a look. He says, if I see anything that I'm not happy about, I'll get in touch with you. If you don't hear from me, carry on.
Well, actually, the building inspector drew the plans for the observatory and send them to Sutton Council. And I used to go up to Sutton Council with the plans and say, what were his name? I forgot.
Ted Redfern?
No, building inspector.
Oh, yeah, go on.
I know, I forgot. Anyway, I used to take the plans up and I said, I'm thinking of doing that. Oh, you need to do this and you need to do that. And he showed me exactly how to draw the plans and what he wanted. And then he says, I need calculations for the dome. I thought, well, that's beyond me straight away. So we got in touch with Nottingham University Architects Department, and they designed the dome with all the calculations, and they took everything into account. The amount of snow that would perhaps fall on it, temperatures, what it's been like over the years, everything took into account.
All based on Newton's shell theory.
Yeah,
there were 26 pages of foolscap, handwritten, all formulas on it. Went back to Sutton Council. Yeah. They looked at it and said, we don't understand this, but if it's done by Nottingham University, it's
it must be right. Yeah. So,
if students did that work for you as well, was that also quite cheap?
That didn't cost anything.
It was free as well, was it?
So really, I mean, if you think about it, we built it. The only thing we did do when we were building the dome, we bought all the ribs, well, the T section, and we built them on a 45-gallon drum, and in that end at wall there's a serving hatch, or there was.
Behind the picture.
Yeah, we used to poke them through there and bend them, and then lay them on the floor, because I'd got a chalk mark of where the radius had to be, or, the shape, and we used to put them there. And then when we got them right, we took them upstairs and fitted them in. And then we bought, I don't know, a dozen aluminium sheets, and they came up here. We bought the sheets. We paid, yeah, they paid for, and then somebody come and pinched them. Can you remember? We had to buy them again. But this time we made short roof on so they couldn't get in. And of course, we had police came up, and I was talking to them, so I says, and explaining what had gone missing. So he says, yeah, see, you've got a burglar alarm. So I says, yes, I says, I'm thinking of changing it. I want to put 250 volts through all things. Nearly had a fit. He says, you can't do that. I said, I'll stop them pinching. But he won't let me do that.
Have you still got the plans?
Plans?
When you designed this place?
No, I gave them to Craig Bradford. While we were doing this, I was observatory director. Everything that went through here went through me. And of course, when I didn't finish, but when I no longer was observatory director, and Craig became the director, I gave him all the plans and everything, so Craig has them. Years later, they says, do you know where deeds are for observatory? I said, yeah, they're back of my wardrobe at home. So I gave him all the deeds as well.
Brilliant.
So to build an observatory, I'm guessing you had to learn a load of new skills. How did you find the whole experience, kind of diving in and learning these things as you go along?
Looking back on it, I thought it was great fun. The funny thing was, well, as you just said, we all learnt new skills. Malcolm became a fantastic plasterer. Malcolm did,
He
didn't
did,
he?
yeah, that's right, yeah.
But when he come round to electrical side of it, everybody walked away and left me to it. Nobody wanted to tell me, especially because I was playing with three-phase. But anyway, that's another story.
I know, yeah. Well, I know when Nige came along, and he was doing some electrical work between various places, I says to him, you stop at 250 volts, a three-phase. You do not play with anything 12 volt on that telescope. That's my job.
It's your domain. It's quite amazing, really, working with Ashfield District Council to buy this plot of land
Yeah.
to build your dream. And here we are, 50 plus years later, again, dealing with Ashfield District Council over multi-million-pound Science Discovery Centre, planetarium. How do you feel of your crazy dream back in the day where you was doing sponsored walks, and now your society, what you created, is dealing with multi-million-pound contracts?
I said to Chris Dakin upstairs one day, because Chris says to me, I hope you don't mind all what I've done to your control systems. I says, no, not at all. I says, if I'd have had the technology that you've got today, I would have installed it same. I says, so you're doing exactly what I would have done. I says, and regarding the reservoir, I take my hat off to you. You know, I'm quite happy for them to make a planetarium, whatever they want to do with it. It's brilliant.
Because it's going to transform the society
Yeah.
Oh, yeah.
beyond all recognition.
But it will be remembered up and down country. They'll know who Sherwood Observatory is,
Absolutely.
and I'm quite proud of that.
Brilliant.
David's book, the first 4 to 6 years, a history of the society, contains a plethora of detail about all the engineering in the building, the dome, and later extension work. So much that we couldn't talk about it all today. But I would like to ask, during the building, was there any particular challenges or problems you overcame that any of you are particularly proud of? Was there like that one moment you thought, I don't know, and then there was a click?
Light bulb. You're talking about light bulb moments.
Yeah.
From my point of view, probably the best light bulb moment is the mechanical drive system on the aperture, because we constructed the aperture and so on and so forth, and I thought, well, we'll think about how we're going to drive it as we go along. And one day I was talking to Gordon and I said, the ideal situation would be a rack and pinion drive, but of course it's curved, you can't do it. Twink, we were using a lot of chain, which there was the story there was a company at Baseford at Nottingham, Marathon Knitwear, and they were having a new machine, a new knitting machine from us down here. And I had to go across there to make sure when the machine was put in line and level and all the electrical connections were made correctly. So the machine that was dragged out, I said to the manager, what are you going to do? What are you doing with this machine? He says, well, we're going to just break it up. I says, right, can I have all the three-phase motors, all the chain and sprocket off? He says, yeah, no problem. He says, we'll take them up to one side, you just get rid of them for us. I brought them up here, Gordon thought it was Christmas. I turned up with hell. But going back, we got a lot of chain. So what we did, I said, well, we can make a rack and pinion out of chain. We should take a strip of metal, weld the chain at each end, and then it'll bend. So we've got a motor with a sprocket on that runs on the chain.
Yeah, it worked fine.
Yeah.
Still working today.
It's still working today. You know, that was a light bulb moment.
I'd like to ask about the telescope, if that's okay, because it's one thing that visitors always mention when they come and go up into the dome. They mention on the telescope, and they're always very impressed, as we all are, with the fact that you built it yourself, 24-inch.
Yep.
Not just the structure and the forks, but also the frame and the mirror. What was the actual telescope made of?
We used. We had another member. His name's Garnet Bradshaw. He worked at Bentinck Pit in the
Maintenance department.
He was in the pit prop department where they repaired them and things. Okay. And I was saying to Garnet one day, I want a 24-inch mirror. I'm going to make a telescope with a 24-inch mirror. I said, so I need a piece of channel, and it wants bending into a circle with the ribs on the outside, so it was flat on the inside. So he says, what size, 24-inch? I says, no. Let's make it 30, because if I ever get invited to get a 30-inch mirror, it'll fit.
There was a bit of redundancy in it.
Yeah, so he made two hoops, one for the top and one for the bottom. And then we got some channel, and we cut it by hacksaw. This is 10-inch by 3.5-inch steel channel, and we cut it by an hacksaw, and we made the square box that the telescope sits on.
Declination box.
And the poles for the telescope were scaffolding poles that we had on roof doing domes, so we just cut scaffolding poles up and welded them in.
Well, why not?
Why not?
It's what you do.
It's what you do.
It's what you do. They did the same thing at Palomar. I'm lying.
In fact, what they did, I'm not sure where we got them from, but we got access to some hexagon nuts with a thread on top and bottom, as if it's to couple something together. And these were about getting up a 2-inch threaded tap that would fit, and it just went inside these aluminium poles. So I put the poles in the vise and just made a great big cross, and we tapped them so we could screw these things in. I've still got that tap at home in my drawer. And God knows where it come from.
And had you done anything like this before? Is this a big upscaling of previous telescopes?
Oh, I mean, I built that observatory, at home.
Yeah.
But I mean, most of the things I used on that were Meccano gearing. But of course, when I'm up here, everything's gone big. But I'm good for engineering. I can make anything.
It certainly sounds like it.
So where we are in 2022, and some new mirror cells are going to be fitted
Yes, so I gather.
into your creation.
Well, the actual fact, Dave Sinden says to me, when we took the mirror up for him to have a look at with the curved bottom, because I wasn't happy how it would behaving at times.
This is the original mirror.
Yeah. So we took this is the one we had from Vacuum
The
Coatings.
original mirror was the laminated one. The one that Gordon's talking about now was
From Vacuum Coatings.
from Vacuum Coatings.
But what they
happened
did
there was he took the remnants of the plate glass mirror we were attempting to make. Well, Gordon had made, but I think I found out why they came apart. I think it's down to ultraviolet light.
could be.
Yeah. Anyway, that's by the by. What Vacuum Coatings did, he took the remnants of the plate glass mirror and the machine that Gordon had built in part exchange for the mirror that's in there now.
But the trouble was, when they got the mirror, to save grinding time, because the glass was only about inch thick or inch and a quarter thick, it wasn't all that thick, and he's got to grind out 5/16 of an inch out of the middle, because it's a 24-inch. You can't go much above F4. Because at F4, it's 8 foot long. And it's becoming, so I think it finished up at F3.95. So to get that curvature, they heated the glass up on a ring and they let it sink in the middle. So it cut down on grinding, but it gave it a round bottom. Well, when I had a word with Dave Sinden about it, because I took it up there for him to have a look, he gave me a program called PLOP, PL or PHLOP, and this used to calculate points that you need to support the mirror. And according to what David says, he says, to be honest, being as your mirror is thicker in the middle than it is on the outside, due to the fact the slumping were greater than it should have been, he says you'll need a 27-point suspension cell. So I built a 27-point suspension a cell according to PLOP, because it gave you all the points. And what PLOP did, it calculated the thickness of the glass and the diameter of the glass, and it divided it into 1/8 tall long pyramids, and it got thousands of them in this glass. And then it calculated how many pyramids that 27's going to support, and it knew exactly where to put them. So thanks to David Sinden, and we made this 27-point suspension cell that supported the mirror.
So you go through building this telescope and the optics. How long did that take from the inaugural meeting, deciding to start?
Well, I started grinding a zone. I laminated a mirror about 3 inch thick, wasn't it?
Yeah, there were 2 pieces with bits in between, loose bits in between.
And I built a grinding machine, and that will go with 4 years.
Wow.
We sent it away to be silvered, and they dropped it.
Ah.
And I said, there's no way I'm going to spend another 4 years grinding another, so we went to vacuum coatings, and they supplied us a mirror.
Do you remember what year the telescope was up and running?
83 was first light.
83.
Yeah, it would be, yeah.
Orion Nebula.
Yeah, that was the first thing we ever shone through, wasn't it?
Yeah.
But with even with duff optics, or not so good optics, we've still seen some good size through that up there.
Can you remember Jack Newton coming?
Yes.
Jack Newton, as astronomer from Canada. He came over to England. I think he were on holiday. He'd heard about us, and he came up here to have a look. And he swung the telescope round on Saturn, I think it was, when we were up here this night, and he says, wow. He says, I have never seen Saturn look like that before. He were absolutely over the moon. Really? I says, well, I'm thinking of changing it into a F10 by using a secondary convex mirror to increase its focal length. And he says, don't do that. Leave it as it is. It's fantastic. Well, I'd already bought the mirror. I'd already ground the things, and I think it were on top of cupboards last time I seen.
That 6-inch corrected mirror.
Yeah.
Yeah, it's in the cupboard, isn't it?
Yeah. Yeah, it's still in there.
That's going in the museum.
Yeah.
Of course, and plus anything else you might have at home.
Yeah.
Ready for the museum.
Well, I've just said to Nigel, I know we're going off subject, I said to Nigel yesterday, he were on about these aerials, I says, I've got an aerial rotator, so a thing that you mount on the end of a pole and you put your aerial on, and when you press the controller at home, it rotates it round. Because I'm a radio am as well. I've got a call sign. Well, I don't go on radio now, but I says, I'll bring it up and let him have it for... Anyway, that's by the by.
I think one of the biggest challenges we had with the telescope was, we've said it more or less from day one, and we're still saying it now. This will never be finished. There'll be always something to modify, improve. I mean, the first drive system was chain and sprocket, as I've already said. Brought it from this broken down knitting machine. But the actual drive to the motor, the original thing, was a disc with holes in, which are rotated with a light and a photo sensor. So it was creating pulses. to drive a motor, but there was, I mean, for instance, the motor that was turning the wheel, that could vary according to temperature conditions and so on and so forth. So we then got onto stepper motors, which what was it? Brian brought those from Nottingham City Hospital, didn't he? Some medical equipment.
I don't know. Steve Norman had something to do with drive.
Yeah, there were step motors with the what they call a bipolar chopper. So we got that lot installed, and then we had problem with the chain. The chain started climbing on one of the teeth, so we decided to rip the chain out and put timing belt pulley. So, at the time I was working in the drawing office down at Monk, so I had all the right information to hand to calculate the pulley size and one thing to make this timing pulleyed reduction gearing. Then we were using you remember the old BBC2 micro computer?
Yeah, I can, yeah.
With the old 5-inch floppy disk. But Gordon had found a program for controlling stepper motors, so he'd spent a lot of time at home creating a program. Well, he had to make two programs, one for sidereal rate and one for lunar rate, which meant 2 disks. That's how things were at the time. The problem was, with the computer sat in there with the vagaries of the temperature, after a while it started to play up. We got another one, but eventually that happened again. So I thought, right, the only one thing to do, I spent some time then designing circuit diagram using TTL logic. So I brought a scope up one night and measured the frequency of the 2 speed pulses for sidereal and lunar rate, and then designed this circuit diagram, which I built on Veriboard. And basically there were two circuits, all run off a 4 megahertz crystal. And then at the end of it, there was 2 outputs going through a switch. So you got a sidereal rate and the other. That was put in. That was running beautifully. Then of course now we've got the go-to conversion, you see. So that was another thing which was highly satisfactory.
The thing is, I'm not sure, but up there, between the motor and the controller and the actual telescope drive, there used to be a big disc, something about this diameter, that was bolted under the forks. And there's a timing belt that used to run. Is it still in there?
Yes.
If it is, I don't know whether you know, but that belongs to a Mercedes-Benz 3.5 truck diesel engine where that come from.
It's all classy stuff, isn't it?
Oh, yeah.
Oh, yeah.
Thank you for listening to part 1 of this special Obscast episode. Part 2 will be available in the coming days.